Construction Math today, we're going to look at inverse trig functions. So on your note taker, you're going to be writing down two examples, but I want you to first of all think about things that are inverses. And the definition in math of inverses are things that undo each other. So think about them, write down two examples on your note taker, share with your partner, and teacher pause the video when students have shared with their partner, call in some non-volunteers, and I'll meet you back here in a minute. Welcome back. Some possible answers I thought of were turning on a light and then turning it off. It resets it to the position it was before we did anything. You could add 5 points to your test score and then take away 5 points from that test score, and you're back to where you started from. Example and its inverses must always leave the situation exactly as it is. If I was to kick you, there's nothing that can undo that. You could kick me back and we both would have sore shins, but there's no way to undo it. So some things have inverses, some actions do not. And we're going to look at math inverses today. So what I want you to do is on your slate, please number from 1 to 6. All right, teacher, pause the video until students have had a chance to do that. Welcome back. What I want you to do is state the inverse of each of these operations. So for number 1, I want the inverse of addition. Number 2, the inverse of division. 3, the inverse of squaring. 4, the inverse of multiplication. 5, the inverse of square rooting. And 6, the inverse of subtraction. So let the students have a chance to finish and pause the video until they're done. Have them show you their slates, and I'll meet you back here in a minute. Welcome back. Here are our answers. The inverse of adding is subtracting. Number 2, the inverse of dividing is multiplying. The inverse of squaring is taking a square root. Number 4, the inverse of multiplication is division. Square rooting's inverse is squaring, and subtraction's inverse is adding. You probably learned most of these when you were learning to solve equations. So the objectives for today. On your note taker, we're going to define terminology. Number 2, we're going to use a calculator to find an inverse trig function. And 3, we're going to calculate inverse trig functions to solve applied problems. So when you're ready, let's go on to the next slide. Okay, so we're going to look at our vocabulary. We have 3 vocabulary squares. I'm going to go over the 3 definitions, and then I'm going to have you pause the video until students have had a chance to complete the vocabulary square. First, we're looking at it's either called the arc cosine or the inverse cosine. Its symbol is cosine to the -1. And what it's finding is the simplest, most basic angle that has cosine of a given value. For example, if I say the cosine of theta is 1/2, what angle is that? And we're going to find out how to find it. The second one is the same thing as the arc sine or the inverse sine. Its abbreviation is sine to the -1. And again, it's the simplest, most basic angle that has sine equivalent to that given value. And the third one is tangent, the arc tangent or the inverse tangent. Same thing, it's finding which angle has the given tangent. So teacher, pause the video and have the students complete the vocabulary squares and then call on them for the meaningful sentence or a definition. And I will meet you back here in a minute. Welcome back. So here's an example of what we're going to learn how to do. If we have a ladder placed against a 40-foot high electrical pole such that it touches the top of the pole, so the ladder is touching the ground and also the top of the pole. If the bottom of the ladder is 10 feet away from the base of the pole, we want to find out what angle does the bottom of the ladder make with the ground. So that's our goal for today, is to be able to figure out how to solve this problem. Your job right now is to fill in the 2 missing values. All right, so first of all, I need you to make sure you understand something about the trig involved from the last lesson. So I want you to figure out which trig function would you use to find theta. Would you find sine, cosine, or tangent? So teacher, pause the video and I'll meet you back here in a minute. Welcome back. Let's go to our slates and let's look at this. All right, I'm going to draw a right triangle, not as pretty as the one I have in my PowerPoint, but at least it'll be a right triangle. Oh, let's erase that and do a little bit better job. It's been a while since I used this slate. All right, that's a little bit better. I wouldn't give myself an A. I probably wouldn't even give myself a C. This side's 12, this side's 28, and here's the angle of reference. So from this point, we always want to find out which sides are we given or looking for. Across from the right angle, this is the hypotenuse. This side helps to make up the angle so that this is the adjacent side. And remember our old friend SOHCAHTOA. It says sine has opposite and hypotenuse. So we have the hypotenuse, but we don't have any knowledge of this, nor do we want to find this. Cosine is the adjacent over the hypotenuse. That's what we have. So we would say that the cosine of this angle is 12 over 28. We can make a statement for that. So we know now that it would be cosine. So let's go ahead and clear this off. Let's go back to our PowerPoint and let's see. Yep, cosine, because we know the adjacent and the hypotenuse. So once you remember which one to find, we can set up the equation. Now, reciprocals and inverses. We have reciprocals in math, and it's a type of inverse, like where we put 1 over the given number. So the reciprocal of 2 is 1/2. The reciprocal of 5 is 1/5. The reciprocal of 2/3 is 3/2. But an inverse means to undo. So the inverse of adding 3 is subtracting 3. The inverse of dividing by 2 is multiplying by 2. And here's the key. An inverse of taking the sine of an angle is taking the inverse sine or the arc sine. So I just need you to fill in these missing terms, and we're going to apply them in just a minute. So teacher, pause the video until students have had a chance to be able to work that, or to put in those words. Welcome back. Let's go on. Now, the arc sine or inverse sine is, those two are equal, but it is not the same thing as 1 over the sine. They are not reciprocals, they're inverses. All right, so the sine or the inverse sine of theta equals x means to find an angle whose sine is equal to x. So again, I need you just to fill in the terms, and we'll be working with this in just a second. Pause the video until students have gotten this information. Welcome back. So here's what I want to do. I want to find what angle has the sine of 1/2. In the olden days, people would look these up on a table, but now we have the modern convenience of a calculator. One thing you need to make sure of is no matter what calculator you're using, is that it is in degree mode. All right. So how do you think you would key this into your calculator? Work with your partner for a second and see what you will come up with. And I need you to be able to figure out what the inverse sine of 1/2 is. And if you come up with 30 degrees, you're absolutely right. So see if you can figure it in on your calculator. All right, pause the video until students have had a chance, because I'm betting most of them have different calculators or different apps on their phones. Welcome back. Here's how I do it. On my calculator, I hit the second button on my graphing calculator and hit sine, so that on the screen it'll hit sine to the -1, or what we call inverse sine. Then I put in 1 divided by 2 to put in the half, and then I hit enter. If you do that, you should get 30 degrees. So play with your calculator, ask for help from your teacher or people around you to make sure you can get 30 degrees. All right, so here's a you try. Using your calculator, I want you to find out what angle has sine of 2/3, or in other words, the inverse sine of 2/3. Number 2, what's the cosine, which angle has the cosine of 5/6? Or what's the inverse cosine of 5/6? And for number 3, what's the inverse tangent of 1/8? Pause the video until you've had a chance to complete that. All right. Write your answers on the slate so that your teacher can see your answers. And then teacher, start the video again when everybody's had a chance to do that. Welcome back. Here's my answers. It said to round them to the nearest tenth of a degree. Always follow the instructions, because if you don't on your tests, you'll be losing some points. So the inverse sine of 2/3 is 41.8 degrees. That means if you take in your calculator and hit sine of 41.8 degrees, you should come up with 2/3, or the decimal equivalent, which is 0.666666, and then a 7. Number 2, I came up with 33.6 degrees, and number 3, I came up with 7.1 degrees. So if you need to pause the video until you have gotten those correct answers, please do so. Welcome back. Now here's an example. We want to find, I've drawn a picture, and I want to find out the angle to the nearest degree. So the first thing I do is decide, it says in the problem it has a tangent of 3/5. So I drew the right triangle. I remember tangent is opposite over adjacent. So the opposite side I labeled 3, the adjacent side I labeled 5. And I drew out a picture just to make it a little more visual for you. And then what I did in order to solve this is I took the inverse tangent of both sides, and I came up with 31.1 degrees. So let's go to our slate right now, and let me see if I can explain it to you. All right, this tangent of theta equals 3/5. What I want to do in this case is I want to solve for theta. It's just like in the problem, like 3x equals 5. You do the inverse of multiplying by 3, so you divide by 3, so x is 5/3. Here I want to get the theta all by itself. So I'm going to do the inverse of tangent. So I'm going to put the inverse of tangent on this side. I'm going to take the inverse tangent of the right side. Tangent and inverse tangent are inverses, so they cancel out. So I get theta equals the inverse tangent of 3/5. And I didn't put my -1 there. So on your calculator, I need you to punch in the inverse tangent of 3/5. And if you did it properly, it should come out to be that the tangent is 31, and I'm rounding it off to the nearest 10, 31.0 degrees. So make sure you can do that, and make sure you get that answer. All right? Pause the video until students have had a chance to work on that. Welcome back. Let's go back to our PowerPoint. And let's look at another example. All right, this one, we want to find it to the nearest tenth of a degree. All right, so I have this. I'm going to go to my slate and let's figure this out. Okay, so I'm going to replicate that problem. That's why I never majored in art. And this was 15 feet, and this is 12 feet. All right, so looking from here, this is the opposite side. This is the adjacent side, because it helps make up the angle. So that says that the tangent of theta is 12/15. Now you can simplify the fraction if you want to, or you don't have to. Your calculator will do everything for you. So now I want to find solve for theta. That's my goal. So I need to get rid of the tangent, so I'm going to do its inverse. So I'm going to take the inverse tangent of the left side. I'm going to take the inverse tangent of the right side. These cancel, so I get theta, and in your calculator, push in inverse tangent of 12/15. All right, if you do it properly, I checked on my calculator, I get 38.7 degrees. So double check and make sure if you can do that math in your calculator, and pause the video if you need to. Welcome back. Let's go back to our PowerPoint and look through my steps. So I set up the trig ratio. Here I go. I knew it was tangent. Then I'm going to take the inverse tangent of both sides, and I got 38.7 degrees. Your calculator is your friend. So you try this one. Find theta. Notice it's in the upper corner instead of the lower corner. So teacher, pause the video, have the students work on this problem, have them compare with their partner, and I'll meet you back here in a minute. Welcome back. Let's go to our slate and see what we can get. All right, we have our triangle here. We have our right angle here. Theta is here. and we have this side 15, and this side is 24. So across from the right angle is always the hypotenuse. Across from the angle I'm given across from theta, that side is the opposite side because it does not help to make up the angle. So I know that's going to be sine, because sine of theta is the opposite over the hypotenuse. So here we go. The sine of theta, my opposite side is 15, my hypotenuse is 24. I want to solve for theta, so I'm going to take the inverse of the sine of both sides. Take the inverse of the right-hand side. These guys are inverses, so they cancel out, so I'm left with theta. In your calculator, go ahead and punch in the values, and I came up with, again, 38.7 degrees. All right, check your answers, and let's see how we did. All right, welcome back. Let's go back to our PowerPoint. And we got that same answer. All right, now let's first of all get ready. We've already put these values in our note taker, and so I want you to draw a diagram and then label your diagram. So teacher, pause the video until all the students have drawn a diagram. All right, let's go to my slate and let's see if I can draw a diagram. All right, here's my pole. All right, and I know from my information, this pole is 40 feet tall. All right, and then I'm going to put a ladder up here. Here's my ladder. My ladder is going to be, my ladder is 20 feet, it says, from the wall. Let me just double check. Oh, no, I don't think it's 20 feet. I think it's just, is this the eraser here? Let me erase that. Go back to my pencil. It's 10 feet. I misread my own notes. All right, so here's the right angle, because the pole should be straight up in the air, and it wants to know the angle it makes with the ground. So make sure that your diagram looks like mine. All right, it said with the ground. So now the next step is to figure out which trig function. So teacher, pause the video until the students have had a chance to figure out the trig function. Welcome back. Let's see. I don't know the length of the ladder, and I don't care at this point. I know this helps make up the angle, so this is the adjacent side. This is the side across from the angle I'm given. That's the opposite side, so I know it's tangent. So here's my equation. The tangent of theta is the opposite side divided by the adjacent side. So I get 40 over 10. Now I want to solve for theta, so I take the inverse trig function of both sides. The inverse tangent of the tangent of theta equals the inverse tangent of 40 over 10. These cancel because they're inverses. So in your calculator, you're going to push the inverse tangent of 40 over 10. Or yes, you could push the inverse tangent of 4, because 40 divided by 10 is 4. So let's see what you get. Pause the video until everybody has an answer. Welcome back. All right, so I know that theta is 76 degrees when I punched it into my calculator. So double check. All right, let's go back to our PowerPoint and see. There's my picture. We solved the problem. There's my answer, and it worked out. So now for closure on your note taker, I want you to fill out these 2 prompts. I now understand, and I need more help with. And teacher, I'll see you here next time. After the video is turned off, ask the students to share this with their partners and call in non-volunteers.